Welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I'm your host, Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a good friend to the universe. It talks me down when I am very stressed and anxious. I am also a lover of Halloween, and today is a short special episode for the holiday, Halloween, which is the best day of the year. And I'm joined in my Podiversity office by my bestie, Connie Gibbs, aka ConStar, a pop culture and social media expert. Come on in, Connie.
Hello. Happy Halloween, Moiya.
Happy Halloween. I'm even wearing my Happy Halloween shirt. Did you see it when you walked in?
I did. It was very cute. It's got a pumpkin on it.
Of course. 'Tis the season. Connie, you were on the pod earlier this year when I was talking about the AAS conference. What's new with you since January?
Literally everything about my life. So there's that. But in short, I moved from New York to Florida.
Yeah, you did.
Moment of silence for that. And I've just been laying low, trying to refuel, connect with my creativity and myself and my purpose. So I've just been trying to be.
That's so valid. And I think the universe appreciates when we just try to be, when we just take a moment to, sit and be mindful of our place in the universe.
Exactly. So that's all.
Yeah.
How about you?
I will say, so far, 2025, much better than 2024, but that's because last year personally was a dumpster inferno.
Yeah.
But some new things for me since January. I have finished the first full draft of my book, Mothers of Invention.
Yes, I am so excited. I'm so excited for that. As bestie, I have some bestie insight privileges, and oh my gosh, cannot wait. So I'm very excited for that. And everyone else should be too.
I hope so. But I'm just so grateful to you because, besties support each other. And Connie was instrumental in getting this book done. The number of times I called Connie crying because I didn't know how to make a muse right in her journal, or I didn't understand what the point of a chapter was. She was so helpful. So thank you, bestie.
Of course. I love to listen. I love to help people try to untangle their stories, even if I have nothing to do with it. It's like, hey, I'm going to ask a question, and you did the rest. So it was really easy on my part, but I'm glad I was there to support you, bestie.
Thank you. Do you love scary things as much as you love asking questions and brainstorming with people?
Not as much, but I've been really brave lately. So
you have.
I've been so brave lately.
I've seen the pictures.
I went to a scary house trail, one of those haunted house things that they have, attractions. There are 3 haunted houses, and I walked through them, and I survived. I did not punch anybody. No one really grabbed at me. So I feel like it was a rousing success. And I've been watching scary shows and movies. And so I've been becoming so brave. I'm just a little marshmallow, and I'm becoming so brave.
I'm so proud of you. Because, I wouldn't have gone to that, Fright Night thing. So hats off.
Yeah.
Well, today we are going to be talking about monsters and scary things, but actually not really, because we're talking about objects in space that have been nicknamed after monsters and scary things. Yeah.
That's going to be exciting.
Or you're just going to see how lame we are.
Oh, well, I love a nerdy naming convention. So if it's, something related to mythology, this is why we're friends. Why I was like, the spark of she knows the stuff about space and mythology, and it's a thing that I love. So I probably will have a good time. So we'll see.
Great. So I just have this list here, and it's a holiday special. I want everyone to get back to celebrating the glorious day. So we're not going to be here too long, but I'm going to start off with vampire stars.
Ooh, okay. So do they suck the energy from other objects.
Yes. Yes, basically. A vampire star is a massive star, usually type B. So they're not the most massive, but they're pretty up there. And they suck material from their companion stars if they happen to be in a pair or a triplet or something. We actually recently discovered that a lot of these vampire stars and other kind of undead stars, because there's a whole category of them, that they often will come in triplets, and so the star is like feeding off of multiple companions. But the cool thing about these vampire stars is that they can turn into a supernova. A B-type star can go supernova on its own, but when it is a vampire and it's actively sucking in material in the form of like hydrogen and plasma from a nearby star, it can reach that supernova point faster.
Sure.
And be more energetic.
What causes that change? Like, not all B-type stars are vampire stars, right?
Right.
So what is there a particular set of circumstances?
If they have a companion and the companion is near enough that its gravity can suck the material away from the other type of star. And we think that most stars are born in pairs. So as common as B-type stars are, there should also be many, many vampire stars.
Oh. What is it in... It's not the master, but in Buffy, it was the master.
In Buffy, yeah. The sire.
Yeah, the sire for one and the other. Yeah, there's always a pairing. There's always a like uncomfortable parasitic relationship between the vampire and their sires and vice versa. So this makes sense.
Oh no, the sire is who turns them into a vampire.
Okay,
So like below the vampire is just like their sycophant, their servant.
Yeah.
It's different depending on the canon.
But it's always some kind of sort of like, oh, this is your torturer and your savior and all that jazz.
Yeah. So that's vampires. They are similar to and sometimes used interchangeably with cannibal stars, which instead of just like sucking material from their companion, they will just eat their companion in one go, like completely engulf the other star. We think that Betelgeuse might be an example of this. Betelgeuse, the big red star in Orion that we are actively waiting to do something exciting next. It's a red giant star, and it might have gotten all of that energy to puff up to its current size by eating its companion.
Wow.
Yeah. And then there's still more. Like there's the zombie star, which I think is also very similar.
So a zombie star, is it something that has collapsed and then the materials come back together and then create another star?
No, I think that would be like a Frankenstar.
Okay. I was thinking of something that died and then came back, but I was trying to think of how stars die. Is like things. Well, I guess it's like explosion and then it comes back in together to form a new star. Tell me, you can just tell me what it is instead of.
I'm just gonna tell you what it is. It is an inactive star, like a white dwarf, that can come alive again for brief periods of time as it gathers material. So it's like a special type of vampire star. And we've seen a few of these examples. These white dwarfs, as material falls onto them, they will experience little novae or novae. And they'll experience a bunch of these before it ultimately becomes a special type of supernova, where a white dwarf star, if it has a companion or multiple, then it will gather their material until it reaches this mass limit of 1.4 times the mass of the sun, and then it will implode in on itself and then explode out and become a supernova.
Because that is what I was trying to imagine, but I don't think I was explaining it right.
That is not what you were trying to. That is not. That's different from what you were saying was talking about like the whole multi-generational life cycle of stars and how the material that's produced in the cores of massive stars then gets spread out into the interstellar medium through supernova explosions, and the gas there then is used to make the next generation of stars, which is why stars get more metal rich over time. But that is a longer term and bigger scale process than what we're talking about.
Gotcha. Okay.
Yes. So there's this example of the zombie star that's gotten a lot of attention in the last couple of years. The star is called T Coronae Borealis, but its nickname is the Blaze Star. It's about 3,000 light years away from us, and it has these little novae every 80 years, and eventually it will go supernova.
Oh, so it's just kind of like pulsing, but like in a different way than stars twinkle? It's doing this every so often, so I was imagining a pulsating kind of vibe, but
yeah,
that seems wrong.
It's not a pulse because it's not like it gets brighter and dimmer slowly.
Okay.
It's a burst. It is a burst every 80 years, and then it goes back to being dead.
Wow. Okay.
Yeah. But these are small explosions. These are just novae, which are much smaller and less powerful than a supernova. A nova is going to be about 100,000 times brighter than the sun. They are also temporary, so they'll happen and they'll go away, and they are only on the surface of the star. A supernova is billions of times as bright as the sun, and they are so powerful that they are structurally devastating to the star. So they can't just be on the surface because the entire surface and stuff underneath it gets destroyed. There are two broad categories of supernova. You have core collapse. That happens with really massive stars that are just so heavy they collapse in on themselves. And you have thermal runaway supernovae. And that happens because there's too much heat inside the star. And it happens under special conditions where the ideal gas law is broken. Do you remember the ideal gas law?
I don't.
Part of the ideal gas law is that as temperature increases, so does pressure.
Okay.
So under normal circumstances inside a star, it's not exactly ideal, but if the temperature inside a star increases, pressure also does. So there's more pressure pushing out, and then the star expands and it is able to cool itself.
Oh.
Right? But when that breaks, if the temperature increases but the pressure doesn't, the star can't expand to let itself cool. So you just get this like runaway temperature that eventually becomes catastrophic and has to explode. And that's what would happen with those white dwarf stars eventually. As they collect more and more material, the novae get brighter and brighter, and it reaches that limit at 1.4 times the mass of the sun, where it has a thermal runaway process. White dwarfs are really dense objects. They are so dense that the matter inside them is called degenerate, which means the atoms are so close together that atoms next to each other, like individual atoms, are kind of sharing electron shells. So they literally cannot move, or else they will violate like quantum rules and be in the same place as each other. They can't follow the ideal gas law because even if they were to expand out, that would make some of them move into the same space as each other. So like they all stay stuck in place and just get hotter and hotter.
You know, you said it was just scary in name, but it sounds real scary. I know it's like happening to stars, but I was just like, wow. And then like the atoms are just trapped.
Trapped. Yes. Like imagine the densest, most packed concert you've ever been to. I hope you have never experienced something this extreme.
Yeah.
Because if you have, how are you alive?
Yeah.
But yeah, it's terrifying for the atoms, I imagine, if they're sentient.
Yeah. In the eventual Pixar movie, when they make an atom, you know, the point of view from an atom. Yeah.
Hi, friends. It's me. Connie went to go see some shooting stars out on the balcony of the office, so I have a couple minutes to share some messages with you. The first message is a huge thank you to all of my patrons who support the show financially each month. As an independent podcaster, it would be so hard to make Pale Blue Pod without your support, so thank you all so much. And I want to give a special shout out and thank you to my sun-like stars, Scott Reynolds, Tom T., Nicole Bartlett, and Ashley Shambo, and Mark Mahoney. You're all golden, and I really appreciate what you do, friends. Thank you. If you want to join this awesome group of people and support an indie podcast on Patreon, you can do that for about $5 a month at patreon.com/palebluepod. You'll get to hear your name on the show, maybe make it onto my patron star chart, and you'll definitely get research notes for pretty much every episode. You can also make a one-time donation and become a supernova, a bright spot in the sky, at the PayPal link in the episode description. Of course, if you can't support the show financially right now, I understand. That's okay. I still love you, and you are still space. The best way to help the show grow is actually to get more people in your life listening to Pale Blue Pod. Clearly, you like the show. So how about you take a link to an episode that you love and you share it with someone who you think would also love it, and then you two can talk about it together, make a little Pale Blue Pod listening club. Doesn't that sound so fun? I think it sounds fun. And any way you can share the pod will definitely earn my gratitude. So thank you in advance. My next message is a podcast recommendation. It's another show in the Multitude Collective, another science show in the Multitude Collective called Tiny Matters. Science shapes our lives every day, but so much of its influence is overlooked or buried in the past because it's so small. But Tiny Matters, an award-winning podcast from the American Chemical Society, is all about tiny things, from molecules to microbes, and how they have a big and often surprising impact on society. From deadly diseases to forensic toxicology to the search for extraterrestrial life, which we all know I'm very interested in, hosts and former scientists Dr. Sam Jones and Dr. Deboki Chakravarty embrace the awe and the messiness of science, also its place in history and today, and how it could impact our world's future. New episodes of Tiny Matters come out every Wednesday, so listen to them wherever you get your podcasts. It seems like those shooting stars have slowed down, so Connie's back inside. We're going to get some warm beverages and get back to these spooky, scary monsters in space. So next we have, this is a little bit of a cheat, the Wolf-Rayet stars or Wolf-Rayet galaxies. Rayet in parentheses. Was that you howling?
Yes. It was very
That was adorable. That was cute.
I mean, I only can do cute. If I was to be a scary movie monster, I'd be the cutest one. I understand.
You would. No, you would have to be the monster in a family Halloween movie. Like you would be Casper. Like you're not.
Yeah, I'd be the monster that's like their friend and tells them about the other monsters.
Yes.
Yeah.
Yes.
Mm-hmm. Absolutely.
And I'm the evil witch in the bog trying to mind control all the villagers, that's
Okay, we're gonna write that.
Work.
Yeah, we're gonna write that. Don't worry about it, guys. We're gonna do that and get it to you someday.
Awesome. But the Wolf-Rayet stars, they're named that not because we think that they're wolfish in any way, but because they were studied by two French astronomers. I think they were both French, Charles Wolf and George the French way Rayet. There are only about 200 of them known in the Milky Way, and they're that means they're pretty rare. We think we only have a couple thousand. But they are massive stars, more than 20 or at least 25 times the mass of the sun, and they're all near the end of their life cycles, so they're rapidly shedding material. They are divided into different classes based on their chemistry. Some of them are nitrogen dominant, some of them are carbon dominant, and then a few of them, apparently this is the rarest type, are oxygen rich, so they have more oxygen than they have carbon.
Okay.
I feel like I saw you make your that's funny face.
I did make that's funny face because, well, for anyone who may not know, there's a sub-genre of storytelling.
I know exactly where you're going.
Yeah. And it just, just like dominant, nitrogen dominant and carbon dominant, but only a few oxygen rich. Something else that might start with an O that's rare in certain fiction subcultures where they have to pair maybe with a dominant nitrogen or carbon.
Girl, just say the words. You're right. These Wolf-Rayet stars, the oxygen-rich ones are the omegas.
Yeah.
Wow. I like to think that the nitrogen-rich ones are the alphas.
Yeah. for sure. Mm-hmm. Yeah,
more than the carbons.
Carbon dominant is just like a standard, like just like, regular. But then for it to be the wolf, I'm sorry, Mr. Rayet. Monsieur Rayet. I'm so sorry.
Thank you for drawing that connection.
Oh, I saw it and I was like, what? And we got my little agenda here and I was like, I'm doing my stuff. I'm reading. And I was like, interesting. Interesting.
I didn't see it.
I thought you were leading me there.
Girl, no. This was a pleasant surprise to arrive at this juncture. Amazing. Oh, serendipitous moment we had.
Indeed. We like to read, guys. We just like to read.
We just love books. Mm-hmm. Oh, and then a Wolf-Rayet galaxy is a galaxy that has like a higher number than expected of these Wolf-Rayet stars.
Mm-hmm.
So we're in the galaxies part. The next one we're going to talk about is ghost galaxies.
Ooh.
That's a good ghost.
Yeah. See, I could be Casper.
You're right. We need to typecast you right now.
Mm-hmm.
Yes. So these ghost galaxies, a real term that astronomers use, they are extremely faint galaxies with few stars and only a couple thousand light years wide, as opposed to the Milky Way, which is about 100,000 light years across.
So they're tiny galaxies, and they're also basically faint with not a lot of stars, huh?
Yes.
Okay.
And we have found a few of them. There were 3 discovered in the Sloan Digital Sky Survey data, probably using some machine learning techniques, which is what we should be calling AI most of the time. Anyway, we found 3 examples of these ghost galaxies. And the interesting thing is that when we age their stars, all of their stars are the same age. And there's this cutoff where there are no stars younger than a certain age. So they all stopped forming at the same time. In all 3 of these galaxies, about 13 billion years ago.
And so it's not from each other. It's just within each galaxy, it's the same time, but not cross between the galaxies, right?
Also cross between the galaxies, kind of, but definitely within each galaxy. Yeah, but across all of the galaxies, yes, even though they are in different places.
Yeah, so they all stopped around forming new stars around the same time?
Yes, Connie, I'm so glad you pointed that out because
spooky.
Yes, it was a universal process that got all of these galaxies to stop forming stars. And the researchers think that universal process was the moment of reionization. These ghost galaxies about 13 billion years ago were all stopped. Their star formation was quenched by the reionization throughout the universe when particles in the universe got ionized, so they became charged across the universe. But these ghost galaxies, they are some of the most pristine examples of the first galaxies ever formed.
Wow.
Yes, in the first billion years after the Big Bang. And they can help us solve a kind of long-standing problem in astronomy called the missing satellite problem. When we run simulations of galaxy formation, it predicts that there are going to be more satellite galaxies around us than we end up observing, actually, around the Milky Way. But maybe they are there. They're just ghosts, and we can't see them.
Oh, so is this one of those things that we've discovered because of the absence of what we normally see?
Great question. Not the absence. The machine learning aspect was really key to this study because the galaxies are so faint that our human perception wouldn't mark those tiny, faint clusters of stars as their own galaxy, like if we could see them at all. So the machine learning algorithms are able to go through the survey data and look for smaller signals than what we would call out.
Nice.
But now we know what to look for, so we don't necessarily need to rely on machine learning to do it. We will, however, rely on machine learning to do a lot of it just because there's so much data to comb through. And that's what machine learning and what people are calling artificial intelligence is really good at doing. It's combing through large sets of data and finding trends in them that are so small, humans might not observe them right away, or at least not like consciously.
Right, right.
So yay, ghosts.
Spooky, for sure.
And we also have a Kraken galaxy.
Release the Kraken.
Yeah. Yes. The Kraken galaxy was the Milky Way's most formidable opponent in its merger history.
Opponent?
Well,
Okay.
you know how I like to do when I'm personifying the galaxies and I turn
course.
their interactions into romance or
It's
violent
necessary
brawls.
for me. That's necessary for me, so I'm intrigued.
Yes. So in the Milky Way's long history of almost 13 billion years, we know it started off smaller
She's so young.
than it is now. So yeah, when it was a wee babe, a wee tot galaxy, we know it was smaller because when we look out at other distant galaxies, which represent the universe as it was very early on, we see that they are smaller. They have fewer stars. Those stars are usually more hydrogen and helium and less heavy elements. So we know that galaxies do evolve. It's a little harder to figure out exactly what happened in our Milky Way's evolutionary history, but there are these special features in our galaxy called globular clusters that help us solve this problem.
Okay.
They're globs. They're clustered globs of stars. They are maybe a few thousand stars that are all gravitationally bound together. Usually they have similar ages and similar chemistries, but like the stars within them do. Though not always. And I actually did a research project in grad school where I used machine learning to study and compare the chemistry and motion of stars in groups to figure out how they formed. Mm-hmm. These globular clusters, because they're so densely packed, they stick together for a long time, billions of years. So they survive massive encounters like galaxy mergers, which means if they formed in a different galaxy and then that galaxy collided or merged with the Milky Way, the globular clusters survived and they have different chemistry than most of the stars in the Milky Way. And they would also have very different motion. These globular clusters don't move in nice circular orbits around the disk like most of our stars do. If their orbits look really perturbed or violent or like irrational in a way, then we can surmise that they are remnants of a merger. So this team looked for some of the oldest globular clusters in the Milky Way that they could and tried to determine which of them came from a different galaxy merging with the Milky Way. And they found 13 globular clusters from a merger that happened about 11 billion years ago. They call that galaxy the Kraken. And even though it's not the biggest galaxy, absolutely, that the Milky Way has ever merged with, that's Gaia Enceladus, which happened about 9 billion years ago. The Kraken merger was relatively the largest and most extreme merger because the Milky Way was smaller 11 billion years ago than it was 9 billion years ago.
Do we know anything about the size of that galaxy? Like, can we tell that information?
Yeah, we know that at the time it was probably about a fifth to a fourth the size of the Milky Way. So still smaller.
So this is the size of the Kraken. It was smaller than the Milky Way at the time, but the merger was so brutal that the globs kind of joined in the Milky Way.
Everything joined in the Milky Way. The Milky Way took all of it.
Okay, it takes all of it. Okay.
Yeah, that's what happens in these galactic mergers. The more massive galaxy will dominate and completely absorb the smaller galaxy.
And there are no layoffs in this scenario.
No, because space is so big that the stars won't touch and they won't be destroyed. In fact, it will be a moment of job creation and economic growth because new stars will form from the mixing gas.
Amazing. I love that.
Yeah. Space monsters.
Sometimes you can't have it all, but in space.
So I hope that was an enjoyable little Halloween holiday special.
Yes, indeed.
For you all. Do you have any more questions about any of these monsters?
No, I think that space itself can seem scary, and then there are monsters. These are some monsters in space. I think someone needs to write some good horror short stories or something about some, giant space omega. Looking for a
Honestly,
nitrogen rich and
people might have done this.
Hydrogen rich.
And I do know exactly who to ask.
Okay,
so
great.
I will report back, Connie.
Okay, we'll have a reading list for everyone shortly.
Great.
But that's it. I learned a lot about monsters in space, and they seem monstrous a little bit. Mm-hmm.
Yeah,
so,
it was a little
spooky.
Okay. Then my final question for you is, for the season, what is your Halloween costume plan?
Oh, yeah, I don't even know. I think it's going to be a potato because I think I'm just going to be in the house. So it might just be a couch potato, but I'll report back if I find something more interesting. But I have some new options now. Mm-hmm. I can figure out how to represent Ghost Galaxy as a Halloween costume. So I'll try to report back on that.
Yeah. Just be as dim as you can and try to suppress your size to like 2,000 light years, That's what it takes.
Exactly.
Be smaller than 2,000 light years.
Check.
Awesome. Okay. I'm really excited for my Halloween costume this year.
What is it? What is it?
Creative.
Wait, you usually do multiple, so...
That's true, yes. And but I only do one new costume every year. I do a week's worth of costumes, but most of them are recycled until the grand new costume of Halloween night. And this year, that's going to be the Tootsie Pop owl.
Yes. This is very exciting. If you see Dr. Moiya somewhere, you may get a Tootsie Pop. So keep an eye out for the bog witch in the Pixar movie we were writing earlier.
Yes, if you're out, in the West Village and you see someone who looks like the Tootsie Pop owl, that's me. Okay, I'll give you a Tootsie Pop.
That's going to be great.
Oh, this should be great. It should be awesome. Oh, okay. Well, that's all I had about monsters up in space. Connie, thank you for doing this holiday special with me. Where can people find you online? What do you got going on?
I don't have a lot public going on right now, but if you want to follow me, you can follow me at ConStar24 on most social media platforms. So come in and say hi if you're listening to this episode.
Okay. All right. Yeah. Connie has some stuff coming up, is working on some things in the background. So stay tuned to Connie's future activities.
Mm-hmm.
Yeah,
mm-hmm.
I think
Real
you'll
soon.
be interested in them, listeners. Yeah.
Mm-hmm.
Awesome. Well, no matter what monster stalks you in the night, remember you are space. Bye. Pale Blue Pod is hosted by me, Dr. Moiya McTier, aka the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.